This is Precalculus Chapter 11, Lesson 2. Hyperbolas. All right, so a hyperbola is really an ellipse turned outward, away from itself. So an ellipse looks like this. What happens is, with the hyperbola, it's almost as though we cut it in half and we reflect it the opposite direction. Yes. So we're going to have the same type of values. We're going to have an A value. The A value is going to be the vertex, right? So if that hyperbola intersects the x-axis, then this, where it intersects it, is going to be our A values. So now our A values and our B values really are not necessarily going to be larger than one another, but the A value is going to lie on the hyperbola. The B value will not. Because our B values are going, so that would be our major axis. That's our vertex, right? Our B value is going to lie on the minor axis, but A doesn't have to be greater than B in this case. It does not. And our focus points always lie inside the curve. So now our focus points are going to be further out than our A values.
So they kind of switch.
They do. They absolutely do switch. All right, so if our focus points and our vertices lie on our x-axis, then the formula is going to be x squared over a squared. It's minus instead of plus. Y squared over b squared equals 1. And because our C value lies further outside than our A value, the C value is going to be A squared plus B squared. Okay, so notice, how to calculate C, we use the opposite sign of the equation, right? When it was an ellipse, C was the square root of A squared minus B squared. They're the opposite. They're the opposite. Got it? I mean, that's just a little key to help you remember. Finding your focus points. But there's also going to be asymptotes. And asymptotes are those imaginary lines that the graph, it sort of helps us graph it, helps us know how wide, how narrow to graph the hyperbola. And it's simply the change in the y-axis over the change in the x-axis. All right, so it's the value that's, so when the vertices lie on the x-axis, your asymptotes are going to be y equals plus minus b over a x, because the b, it's think slope, because the b lies on the b lies on the y-axis, the a lies on the x-axis. Are you kind of relating that to slope, the y over the x? Because guess what happens when it's like this? All right, so then you're going to have these asymptotes that you draw to help you know how wide the hyperbola is. This is your asymptotes. That's how we're going to calculate it. these imaginary lines. It's going to drive how we graph the hyperbola. If, on the other hand, the vertices lie on the y-axis, that's our A value. So our focus points still lie inside that curve. All right, so the hyperbola curves and the ellipse, it curves about the focus points. Our B values lie on the x-axis. And now instead of x being first, because A dictates what value goes first. So because A's on our y-axis, it's going to be y squared over A squared minus x squared over B squared equals 1. Remember, with an ellipse, it didn't matter. We could have put A under y or A under x, but because it's minus, whatever axis the A is on is that term, dictates what term goes first. Does that make sense? So now our asymptotes are going to be A over B, plus and minus A over BX, because the A value is on our y-axis. And remember, slope is the change in y over the change in x, right? And B is on our x-axis. Make sense? Okay. So let's walk through example 1. All right, show that the graph of the equation 9x squared minus 4y squared equals 36. Already I can tell what my major axis is. Which one is it going to be? The x, because it's first. Okay, so already in my mind, I know that I'm graphing A on the x-axis because it's the first term. But even the hyperbola is set equal to 1, so that is where I start by dividing every term by the 36 to set it equal to 1. My denominator under x will be 4 as we simplify, right? And my denominator under y will be 6. So now you see how our B value, 9, exactly, 9.
I said, wait.
Yes, thank you. I knew, I'm like, square root of 6, that doesn't work, and this was a perfect square. So what is my A value?
2 squared.
It's 2, yes. And my B value is going to be 3. My C value is now 4 plus 9 because we're adding, right? So my C value is going to be the square root of 13, which is between 3 and 4. Because 3 squared is 9, 4 squared is 16. That's how I figured that out. Got it? All right, I need my asymptotes. To graph a hyperbola, you begin with the asymptote. All right, so it's going to be, because x is first, I need my change in y over my change in x. Got it? So my asymptotes are going to be y equals plus and minus 3 over 2x. Change in y, change in x. All right, so I'm going to graph that. One's going to be a negative slope, one's going to be a positive slope. And I'm going to start at the origin because this has not been transformed. Where do I go to? All right, so I'm going to start at the origin. I'm going to go up 3 and back 2. I'll go down 3 and over to here. So here's one asymptote. The other one will just be the opposite of that. You see what I'm doing? It's always going to make an X, right? I just went up 3 and over 2 this way, down 3 and back 2 that way. All right, so my hyperbola is going to approach those lines. All right, my A value is 2 and negative 2. I don't really have to plot my B value. It doesn't lie on the hyperbola like the B value did on the ellipse. And I said my C value is going to be here. All right, so I'm just going to approach that asymptote from both directions. See how I drew that? I'm just going to approach that asymptote from both directions. So the asymptotes help you graph it. Graph the hyperbola. The second example is exactly like this, but they want you to graph on your calculator. We're not going to graph on our calculator. All right. Now let's think. What's the only point that lies on the hyperbola? The A values. We know that that's a point that lies on the hyperbola. Okay. C doesn't and B doesn't. On the ellipse, A and B both lie on the ellipse. Okay, so keeping that in our minds as we work through some problems. All right, look at example 3. Find the equation of a hyperbola that has vertices of 0, 1, and 0, negative 1. Okay, that should tell us what is our major axis. What's our major axis? Y has to be our major axis. So in my mind, I know my hyperbola is going to look like that. All right, I'm going to go ahead and graph the 1 and the negative 1. All right. And it passes through 3 square root of 2. Well, that's an X, that's a Y value. All right. Now, having this information, what is my equation going to look like? What's going to be first? Y squared over A squared. What's A? What's my A value? 1. 1 squared is 1. Minus X squared over B squared equals 1. Can I solve for B? I can't graph this without having both A and B. They gave me a point. I'm going to substitute that point in here and solve for B. All right, what's the square root of 2 squared?
2.
It's 2. 2 over 1 is just 2. Minus 3 squared is
9.
9 over B squared equals 1. We'll divide by 2. So we have negative 9 over B squared is 1/2. All right, how are we going to solve it from here?
Would you multiply by 9 on both sides? To get B squared by itself?
Yes. But why didn't that? Oh, wait. Y'all, I divided instead of subtracting.
Yeah, I was scared.
Thank you. I know. I divided instead. So that's 2. Let's subtract 2. That's negative 1. There we go. Boom. like, I did something wrong because this isn't going to work. Change them both to positive because we can, right? 9 over what equals 1?
9.
So b squared has to equal
3.
That's right. B has to equal 3. Right? Because only 9 over 9 is 1, and that 9 in the denominator is squared, so B has to be 3. All right, my A value is on my y-axis, so that's in the numerator when I'm thinking my asymptotes, right? My A value is 1, so it's going to be y equals plus minus 1. My B value is 3x, and I'll do my asymptotes. All right, we'll start at the origin, and we'll go up 1 over 3, down 1 over 3. Here's one asymptote. It's going to be a real skinny hyperbola. Actually, it's going to be maybe a real wide one. And then we'll go up 1 over 3. It makes like a rectangle. Like if I were to draw all of these together, you see the little rectangle kind of. Actually, it's going to be a very wide one. I was thinking the vertexes were on the x-axis, but they're not. All right, and what is my C value? It's the square root of, what's my C value? Square root of
A squared minus B squared.
Plus, which is what? Square root of?
Wait, what was that A again?
1, B is 3. So it's the square root of
4.
10. A squared plus B squared.
Oh.
Square root of 10, right? Which is past 3. Well, past 3. So that's going to be my C value. All right, but my hyperbola is going to be this wide, very wide hyperbola. All right.